Okay, so yes, this is monitoring and metrics with Prometheus and Grafana, and we're going to look at using .NET Core code to leverage this. So there's going to be quite a lot of demo code that I'm going to show in this talk. Hopefully most of it will be in demo, and there's actually more demo and more sort of all the setup code that I use for this I have shared, and I'm going to link to it at the end of it. So all of that will be available for you to look in your own time with instructions of how to run the demos yourself as well. Okay. So things go wrong, and often we don't have the information we need at hand to diagnose what's gone on. And you look at sort of a typical IT approach, then there's a problem that occurs. Maybe they'll start by rebooting a server or killing a pod, and if that doesn't fix it, then maybe they'll reboot the server next to it or kill the node. And if that doesn't work, maybe they'll reboot all the servers or run a redeployment. And if that doesn't work, they'll probably blame the developers because it's usually their fault anyway. There was an interesting Microsoft study done way back in 2001. It showed that orgs with the highest service levels rebooted servers 20 times less frequently than the lower performers. And the key to that was that they were able to have the information at hand to diagnose the problems. And sometimes we can provide so much sort of telemetry and logging information, or just not enough at all, that you can't really see the wood for the trees. So this talk is about enabling you to see the big picture, right? Using the right kind of telemetry, the right kind of monitoring to get an aggregate view of what's going on. Because often you don't necessarily know that a problem is a failure in an application. Could be like a bug, a defect in the code, a failure in the environment, like a networking problem or a configuration problem, or perhaps it's something completely external to your solution, like a massive denial of service attack going on. The 2015 State of DevOps report showed that high performers can resolve production incidents 168 times faster than their peers. They have a mean time to recovery of minutes versus days in the medium performer. And the top two practices that drove this was version control for DevOps, and number two, telemetry and proactive monitoring. So we're going to focus on monitoring, but also cover kind of the DevOps of that as well. This is a screenshot of a Grafana dashboard. I think first of all, right, this is very visually appealing. This is the kind of thing you'd like to have to look at and see what's going on within your application. But if you look carefully at this, what you'll see is that these metrics are not all sort of infrastructure technical metrics. In fact, the things that you've got at the top of this particular application, talking about signups and logins, are perhaps key indicators for whether the business of this application is performing as you'd expect. Are the right number of users we'd expect in there? Are the support calls of a level that it should sort of show that users are happy or unhappy? And I think there are several layers of metric you should be interested in. You want to know, is the business performing fundamentally? And then is the application working as you'd expect underneath that? And then to help you diagnose further, perhaps infrastructure really sort of comes towards the end of that line of inquiry. So I'm going to show you how to create a dashboard like this and how you can run this tooling easily on your own machines, because monitoring should be something that you think about early in the development process. It should be easily available to you as a developer and be available in every environment. So Grafana is very much a tool for creating dashboards like this, but Prometheus provides is a time series database that acts as a source of information. So I always get very curious about the names of these things, and they don't explain on Prometheus's site how they named it. But Prometheus is a character from the classics. It was a titan that gave man fire, and Zeus didn't like that, so he sentenced him to be chained up every day and have an eagle come along and eat out his liver, and then they sort of reset the clock and he had to go through it all again. But perhaps the name Prometheus comes from the fact that he was associated with the idea of being a scientist, because he gave man fire, and sort of the experimental method. And Prometheus is there to give you the metrics to understand your application. So as I said, it's a time series database. So a time series is basically any stream of data that has time on one axis. And it's a database because it's storing basically a set of time series. So you think about it a bit like this. If you think about a bouncer in a nightclub with a clicker on the door, and every time somebody comes in, he clicks a number up, and every time somebody goes out, he clicks to tick it down. And maybe Prometheus is the engine that's looking at sort of all of the bouncers across all of the nightclubs and walking up to them periodically, or maybe phoning them and saying, "What's your number right now? What's your number right now?" And it's doing this, typically this scrape of all of your applications, saying, "Give me your metrics right now, and then I'm going to store them in my database, and you can query for them." And it provides metrics that look essentially like this. So here we've got a metric called API HTTP requests total. You can guess it's probably a counter of HTTP requests to your API. And you can apply labels, which provide dimensions to that metric. So in this case, we're looking at a label for the HTTP method that's been used in that call, and in this particular case, the handler that's handling those messages. So a time series is every unique, you get a time series created for every unique combination of a metric and its labels. And it stores 4 different kinds of metric. The most basic is a counter. And literally a counter is a number that just carries on accumulating. So here we can see a garbage collection count. It's a typical sort of .NET counter that you might see, and it's got a label applied to capture which generation of garbage collection we're looking at. A gauge is a metric that you would use to measure a number that can go up or down. So here we're looking at a metric that's counting the number of threads in the process. And most of the time, a counter and a gauge, just using those types will give you a hell of a lot of information. One of the more sort of third type now, the histogram, and this is very closely related to the summary type, so I'm not going to go into summary. A histogram is basically, it's a count that goes across a number of buckets. So the most common sort of seen use case of this is measuring how long it takes to service an HTTP request. And that's what we're looking at here. And what you can see is there are a number of buckets. And in this case, you can see you've got this less than or equals rule. And that's saying if the request is less than this many seconds, and we'll count within, put a count within in that particular bucket. And you can see here that there's been 2,206 requests that happened within an infinite amount of time. And then as we sort of go down this list, you can sort of see it start to come down. There were only 549 requests that were done in 0.002 seconds. So this is really useful if you have an SLA. If you need to have a certain percentage of all your requests execute in sort of less than 500 milliseconds, you want to have like 95% of all your requests, say, within less than a certain amount of time. A histogram is a great metric that you can use to see how you're doing. Okay, so let's get into actually looking at this in practice. Right. So I've got absolutely nothing set up at this point on my machine. And in running this demo, I'm going to set up Prometheus, I'm going to set up Grafana and a sample .NET application. So that's done now, and they're all running. So you see, it's not difficult to get all this up and going. And I'm going to share the Docker containers I'm using to demonstrate this. But they all work from base images. There's very little extra work that I've done. So it's a really easy tool to get up and running with. And the interesting thing about Prometheus is that it requires very little from your application to use this. Your application needs to serve up the metrics endpoint, and there's a library that helps you do that. And then you can configure Prometheus to come along and scrape your application endpoint, your metrics application endpoint. So I've got that set up, and you can see here, if we go to the targets page, there's a couple of endpoints that Prometheus is looking at, and it's set up to scrape them every 5 seconds or so. First of all, it's scraping itself. It's quite a common thing to do with Prometheus. And then it's scraping a very simple .NET application that I set up that we'll take a brief look at in a sec. A lot of the time when you're in Prometheus, you're going to be using it to check that the metrics you're collecting look like what you expect. It's kind of a testing ground before you get them into a graphing dashboard tool like Grafana. So one of the metrics that Prometheus captures is so HTTP requests against itself. So if I run this metric, we can see all of the various combinations of labels that are collected. So we can see that if we look at this, we can see it's broken down by a number of dimensions. We've got the status code that's returned by a call, the endpoint that's being called, the instance that's running, and then the job, the Prometheus job that's been set up to scrape this particular endpoint. And we've just got a count at the end. So typically I want to sort of drill down on a particular endpoint. So I can filter on any metric by any of its labels. So for example, I can specify that I'm only interested in looking at the handler endpoint. If I do that, we've just limited our return results to that one metric, has a value of 25, and we can put it on a graph. With a total, generally you're going to be interested in how that's changing over time to give you a view of the rate. So Prometheus provides a number of functions that allow you to aggregate over a metric. So I can, for example, change this to be looking over a 5-minute window. And not much has changed there because we haven't been running Prometheus for more than 5 minutes. So this is just a counter that's been going up all the way through the past 5 minutes. So if I start to lower this rate down, it's going to steepen that graph, and we can see now we're landing on sort of the 5-minute rate. We're scraping every 5 seconds or so, so it's not surprising. It's sort of flattened out at 0.2 requests per second. I can sort of bring this number down to get a sharper and sharper, sort of more accurate graph. But what you'll find is sort of the smaller the window, the spikier a graph will tend to get. So you need to decide whether you're interested in sort of smoothing your data to get a sort of a wider moving average, or you're going in to look at sort of second to second changes. If you go too far though, then you'll find this will happen. Here, it's failed to render the graph because Prometheus is only going to timestamp a metric when it reads it. The client doesn't keep track of when its metrics are published. It's just going to give you the current state of all of the counters and gauges when Prometheus scrapes the endpoint. Prometheus attaches a timestamp. So Prometheus is scraping every 5 seconds. There's going to be an entry in its database every 5 seconds. And it can't calculate a rate from one data point. It needs a minimum of 2. So that's why only when we put in 15 seconds or so do we see a value. Okay, so that's looking at a basic counter, and it's part of Prometheus. It's not that interesting. We'd really like to get some sort of proper metrics from a .NET application. So to help with that, I'm going to show you the .NET application I'm using in a second, but I'm going to use a tool called JMeter, which is a very popular open source load testing tool, which is going to fire some traffic in against a .NET application that I've set up. And I won't sort of spend too much time dwelling on this. There is a really good Pluralsight course in it if you want to find out about it. But this tool will let me specify an HTTP request and some rules around that, some variation. I'm just going to set this up to make a number of simple calls against my .NET application. I'm going to start that going to create some traffic. So this is the .NET application that we're going to look at. It's very, very close to the default web API application that you would get if you spun up .NET new web API app. You can see here that I've added in the Prometheus-net.ASP.NET Core client library, and that's going to give us the ability to create Prometheus metrics in our application. But to get going very quickly, you can add some simple ASP.NET Core level metrics out of the box. And all I need to do that is I need to come into the sort of standard startup method and make 2 extension calls. The first is use HTTP metrics in the Prometheus namespace, and that's going to start capturing basic HTTP metrics from all of the controller endpoints. And then map metrics is going to expose the metrics endpoint for Prometheus to be able to scrape. So I can show you that now if I come to should remember the endpoint correctly. Oh, no, I haven't got the endpoint correct. Let me just remind myself what I set it as. There we go. Let's grab that. You know, done. I've gone and exposed it on a different port to the outside world, and I can't remember which. It doesn't matter. I'll come back to that in a second. You'll see the endpoint in a sec. Yeah, I'm not publishing that port outside of my Docker network, which is why you won't see it. But never mind. Let's come back to the app, and I'll show you the graph of the metrics in 1 second through Prometheus. So this is the one controller in this application. It's the orders controller, and the idea of this application is like we're in a factory, and maybe it's a factory that is assembling sort of components, lots of robots running around, and they all need sprockets and widgets, and other services are constantly calling this thing to place an order for the components that they need. So they call this place order endpoint, ask for a product, and it's either going to be in stock or it's not. So a call to this endpoint will look like this. So here we're going to ask for a sprocket, we're going to ask for 10 of them, and we make that call, and we'll get a message back if the order is accepted. If we place a request for something that doesn't exist, then we might get an error to say, oh, this product isn't in the catalog. But there is a stock level, and that's sort of being depleted every time we make a call here. So if we drop back to Prometheus, and we come back to the graph, then we can see HTTP request total is a metric that's been published as sort of one of these standard metrics that were available through the Prometheus library. So I'll run this guy. We can see that our place order action on the orders controller has been picked up, and we can see the different response types that are being returned from calling that particular method. And I can narrow this down so that I'm sort of limiting it to look at the orders controller. And then, much as before, I can place a rate over that, and I can graph it, and I'm going to bring it down to 15 seconds, and put that on a graph. There we go. We can see our endpoint, and I can zoom in on this a little bit, and you can see from the categories here that we've got some requests are coming back with a 202 accepted. There's the one sort of 404 that you just saw me issue for a product that doesn't exist. But we've got a whole load of 409s, a conflict message. So there's something mysterious that's going wrong here. And the standard HTTP metrics are telling us it's a problem, but we don't really have the information that we need to know what's going wrong. So let's flick over and have a look at a Grafana instance now. And I'll just show you how, once you've sort of established a metric that you might be interested in, how you can then configure Grafana. And again, this is a brand new instance, not configured before. I need to do two things. First of all, I need to tell it about Prometheus. So I'm just going to configure my Prometheus endpoint. Give it a data source. That's done. And having set up the data source, I can now create a dashboard. So as soon as I add a panel here, it's picked up that Prometheus is my default data source, and it has IntelliSense, so it can see all of the metrics that are exposed from that underlying Prometheus resource. And you can see here that I can graph the metric that I had previously. It's giving me, again, an easy way of completing the metric through auto completion. So it's extremely user-friendly for creating a new metric. And here we go. We can see that graph we were just looking at. I'm just going to bring it into a slightly more interesting window of time. And these are sort of the same pretty ugly graph labels that I saw before, but I can tidy that up. It's very easy to use a legend based on the labels that I've provided. So for example, if I do this, we can see now that we've got some nice, easy to read labels here. We could give this a title, like, and we've got a nice dashboard. But so this is only sort of a part of the picture, right? This is the same information we were looking at before, but we can do better by thinking about sort of a less application sort of infrastructure level metric of HTTP requests, and perhaps thinking a little bit more about what is the business of this application. So if I come back to the code here, and I'm going to dig a little bit more into the implementation of this orders controller. So you can see here that we're making this check to try and place an order from an injected product catalog. If I jump into the product catalog, then you can see that we are setting up just a little concurrent dictionary here to store the levels of each of the products that we're offering. And on these 2 lines of code, I'm creating a custom metric. In this case, it's a gauge, which is going to track the current stock level. So with a gauge, you need to give it a name, you need to give it some help text, and then you can give it any number of labels. And the only label I'm using in this case is product. And every time an order is placed, this line here is going to go up to the static stock gauge that we set up, apply the current product label, and just call dec to decrease the amount by 1. And then similarly, whenever we call our restock, which will either be adding a brand new product or updating the stock level of an existing product, it's 1 line of code to just set the new stock level or increment the stock level. And I'll let you sort of study this when you're looking at the demo code. It's a little bit involved because it's been written to be thread safe. The way this is getting called, you'll spot in the startup method, I'm registering a background hosted service called Restocker, which runs periodically to do the update. But now we've got a much more interesting application level metric. And rather than sort of adding that in by hand, I'm going to flick over to a second instance of Grafana that I've got running that shows a pre-configured dashboard. So we come in here, I've just sort of thrown a few different representations of a similar set of data, but we can see that same graph that we created earlier. But we can also see the new stock levels of all of our graphs based on querying the gauge metric that we just set up. And you can see here that what's happening is we're placing levels for widgets, which are sort of running down to 0. And then there's a whole period of time where there is no widget stock available before the restock kicks in and brings them up again. And you can see how this correlates to the failed requests above. So this is giving us that extra level of application insight to understand what's going on. The same information around the product levels is being displayed on all of these graphs. It's just demonstrating that there are lots and lots of different ways of representing data in Grafana that you can add in. And I'm not a designer. Maybe we could get Lex on this and she could do something that's a bit more appealing. One thing I would say is, and I've seen this happen, don't make the mistake with Grafana of creating the dashboard which is 10 stories high. That's no good to man nor beast. You know, with this kind of thing, radiating information around the office can be really powerful. You don't want things that you have to page through or endlessly scroll. The trick there is to create multiple dashboards which give you specific views on different areas of your application, and you can set up click-throughs to drill through into more information. Show the important business level metrics at the top, and it's amazing how quickly you'll get used to the shape of normal. When you see sort of this kind of thing displayed all the time, you can tell at a glance when something is wrong. What I don't have time to show you is that it's very easy in both Prometheus and Grafana to set up alerts, and there are built-in integrations to a number of different popular alerting tools such as PagerDuty and OpsGenie and so on. And you can put threshold levels on your graphs, like I've sort of done here, to give you an indication of when something is in the danger zone. Another really interesting feature that you can set up that I will show you is what Etsy, when they introduced it, called their unrivaled magical vertical line technology. What they realized is that things most often go wrong when there is change in the system. And one of the most common forms of change is when you release a new version of your application. And it's super easy to set up annotations from Azure DevOps, which I know a lot of you will be using to release your code. and a number of other sort of common release technologies to show you when a release happens. So I'll show you how easy that is to set up. The first thing I'm going to do is use a tool called ngrok to expose my local machine to the internet. I'm just going to grab the URL for that, and then I'm going to leap over to a .NET Azure DevOps project that I set up earlier, and I'm in the service hooks section of the product settings. You'll see that down here, one of the available plugins is Grafana. I can come into this, and I'm going to specify that I want to be notified about all releases. I'm going to supply the URL to my Grafana instance, and then for security, I need to supply an API token. As I sort of literally just set this instance just now, I'm going to need to configure that. So I'm going to come to API keys and create a new API key. It needs to have the edit permission to be able to drop annotations in. I'll make this available for a while, and I just need to grab that API key and then come back over to DevOps, paste it in, and you can use a release tag to sort of help you filter on releases. But you can see it's now plugged into my solution, and it can see my Acme dashboard. So having set that up, when I now go and spin off a release, and there's been this very scary warning all day about releases taking ages in DevOps. I hope they sorted that out. This release doesn't do anything particularly interesting other than sort of start, hang around for a bit and finish. But with that release having been queued, let me just go and see how it's getting on. We just now need to wait for the internet gods to assign me an agent. And you'll notice that I've not actually had to configure anything in Grafana itself. But if we drop back over to our dashboard now, then we can see this is just kicked off here to show this that release has kicked off and completed. And I'll tell you that having that annotation against your graphs can so often highlight, the particularly buggy microservice that went out that caused all of the other metrics to sort of go crazy. It can save untold amounts of time. So if you do nothing else, or take nothing else away from this talk, putting in annotations on Grafana, I can tell you, will save you time and money in spades. You'll find that I've sort of dropped straight into demo 5 here. Look at the README in the demo, which I'll link at the end. It's going to show you how I set up the Grafana and Prometheus in Docker. It's going to show you how you can configure this in Kubernetes so that you don't need to manually configure endpoints. There are tools available that allow it to automatically discover pods and services and capture their sort of their metrics endpoints and scrape them. And all you need to do is provide particular annotations on your containers to do that. Grafana itself will let you export all of the dashboards that you create as JSON. And that's exactly what I did here. I captured the JSON of the Acme dashboard that I created, and you can see in the Docker file where I'm pulling that definition into my Grafana instance. It's a really simple setup script, which enables you then to keep your dashboards under source control with your applications so that you can evolve them with your applications, and you can run them then easily from any environment, not just production. Treat them as equal footing with all of your code and bring them up to all the environments. Okay, so let's get back to the slides. Okay, just in the interest of time, I'm going to skip past these slides, which just give you a bit of an insight into what a production-ready Prometheus infrastructure may look like. Really, you only need a single instance of it in the cluster, but if you need to make it highly available, you can do that. You can also add in something called a push gateway, which will enable you to capture metrics from those short-lived jobs that perhaps are so quick they're not around for the scrape interval of Prometheus. You can also plug in Prometheus's alert manager to raise alerts and a number of different client tools. Okay. So one other thing that I would say, the sort of really interesting thing that came out of this metrics movement, is the fact that it becomes possible to spot anomalies without having to even specify what an anomaly looks like. And this is really exemplified by Netflix, who did a lot of the work to push this through, where they realized that a lot of their metrics had a Gaussian distribution. So you could tell if there was a particular server that was playing up when its metrics went into sort of, maybe the third standard deviation compared to the average of the servers in the farm. And they started following the process of literally just killing the server that was showing an anomaly and bringing up a new one. And they saw a massive improvement in their service levels by following that approach. Maybe you don't want to be that extreme in your 3-server solution, but certainly you can use that to drive metrics when things are going wrong in part of your infrastructure. So hopefully you can see the value in doing this and getting those sort of information radiators out within your application. There's tons of opportunity here to save yourself time and worry when you have a problem in production. And I would say this, if something doesn't have a metric, if you can't think of a metric for it when you're sort of doing your story planning, it's probably not worth building. If something really has business value, there should be a metric that you can apply to it. And that applies equally to your DevOps pipelines too. We have metrics around the number of bugs that we're raising in a sprint, how long it's taking to get a story through the pipeline. These sort of metrics can provide useful insights into how well your process itself is working. So I've been James Weld. I run a meetup of my own, along with Dan Clark. I run the Azure Oxford meetup. Dan also looks after the .NET Oxford meetup, which meets regularly online, and we've sort of done a similar job of just switching over to the .NET meetup during the course of COVID, but I'm sure we'll be back in full flight soon. If you want to look at the code, then you can find it on my GitHub here. It's got the very obvious name of monitoring. If you've got any questions that you don't want to ask now, then you can tap me on Twitter or send me a message on LinkedIn. And that is the end of my talk. And I think I overran a bit. I'm sorry, Kevin.